Yes, I'm wearing yellow green. Hello guys! Welcome back to my YT channel. This is again Nepomuceno Eternal Voice. My God, my gosh. A YouTube content creator. Okay. Let's start now. Why is too much introductory part? Okay. Sige, mag-start na tayo. Okay, go. Okay. So, extraction. If we say about extraction, as I said over and over again, this is related to crystallization, drying, and evaporation. Okay? Like that. Okay, science lovers, pasok! Okay. Like that. Okay. So I have to review not review, I want to read the problem. Oh guys, really diba? Okay. Kakaloka. So, listen very, very carefully. What's this? Okay. Chemical Engineering Board Examination 1987. So this was based on old chemical engineers licensure examination regulated by the PRC. Okay, a liquid extraction vessel. That's why I don't solve, because it will not become a challenge if I will solve first. Okay, a liquid extraction vessel is used to separate a solute, capital S, wow, from water, W. Okay, the solute is transferred to an organic solvent, capital O, that is immiscible in water. What do you mean by immiscible? It will never be dissolved. So insoluble. Okay, like that. So meaning if it is insoluble for water, that is hydrophobic substance. Again, review the basic theory. And if it is dissolved to water, that is hydrophilic substance. Review the technical terms. Given the process diagram below, calculate the following. Letter A, the organic solvent required to produce a water product containing 0.5% of solute. Wow. The fraction of the solute in the feed that is recovered in the organic solvent product. Okay. So in here, this is very unique because the given is shown in a drawing or an illustration, something like that. So it doesn't reflected in the paragraph, because that is more difficult. If you put that in the paragraph, and we don't know the streams meaning the flow, where it goes out, where it comes in. But if there are problems like that, it is a plus factor, because we know the direction of our feed and then our product, something like that. We know the streams, as streams, streams. Okay, just like the distillation, we have the streams like the distillate and the overhead product and the bottom product and the feed, something like just like that also in extraction or in most of the physical and chemical separation processes. So, meaning to say, overall material balance is very important here. And also the component balance, and sometimes, not really all the time, the energy balance also. Okay, but in energy balance, usually you can have the momentum transfer, the fluid mechanics, fluid flow. But in most of the times in chemical engineering problems with respect to physical and chemical separation processes, okay, concentrations involve or solubilities that would refer to that component balance, especially in mass transfer. Okay, mass transfer. And then this extraction like that, crystallization, because it's focusing on the solubilities and the concentrations of your streams or your flows. FLOWS, not flow, FLAW, because that is mistakes, imperfection. Again, ang katunog siya, rhyme, RHYME. It's not flow, but flow. Okay? Flows and streams. You got a point? It's very important to note that one, okay? The direction where your fluid or liquid flows, right? Okay, now I need to illustrate now because it's in the drawing. So meaning to say, in the actual board examination, chemical engineer's licensure examination, this has been reflected in the test paper, the drawing itself. Okay, because it is patterned there. This specific question in the 1987 chemical engineer's examination. Okay, so how can we do this? So guys, build your foundation in overall material balance, component balance, and energy balance. Okay, and don't forget the scientific laws and scientific theories involved in it also. Especially if you are dealing with this particular topic, what are the scientific laws and scientific theories involved? Who are those scientists discovered this? Something like that. When I was in college, I started develop that one. Though in high school, I memorized already some. Okay, who discovered radiation, radioactivity, something who is the father of modern chemistry, who is the father of physics. Okay, and then when I go to college, I still have that culture and attitude. Nobody teaches me to do that. That's my own initiative only. Okay, when I was in first year college, it's already in my brain cells. So I have now already the stack knowledge. Plus the new topics that coming in taught in first year college. So it will become more, just like a pool of knowledge. Okay, POOL, meaning a place of information in your brain cells. And then it was developed, improved, something like that. And then it become, shall we say, plenty. Wow, plenty. What do you mean by plenty? Several? Plenty, several, or shall we say many, or multiple? Okay, those are the same meaning, right? Several, plenty, many, and multiple, meaning more than one. You get the point? So that's the same thing, right? Okay. So like that. So you should understand and memorize, including the scientists involved in that particular topic. Of course, I don't tell my classmates for that because that is my internal culture as a student. Maybe they will hit me, okay, and they will punch me because I will add jobs for them or I will add tasks for them because they don't like something like that. Okay, so I have my own way of doing my study and know how I retain the information in my brain cells, and they have also their own something like that. At a young age, of course, we are only focusing for ourselves to pass the subjects like that. Okay, it is just only at this point that I do this to share the academic information because I want to share. Okay, because I'm done in studying those stuffs like that. Okay, and it's good to share. Okay? Something like that. But I was in college. I don't tell, Hoy, Maria, mag-memorize ka ani ha, para madaghan tag matunan. Wako ni ana. I just keep it on myself at a very young age. Okay? And then I developed that culture when I was in college, from first year college to fifth year college. Okay? In taking up Bachelor of Science in Chemical Engineering. Okay? Like that. Okay. So, I need to get it back up. Oh my gosh. Oh my gosh! Nahurot good siya, guys, ang akong pentel pens. How can I do that? Can I do it by using just a ball pen? Can you see clearly if I write in ball pen here? In my explanation later. I don't know. Nawala dyan ko sa screen. My gosh, nawala sa screen. Sorry, mga friends. Okay, nawala ako sa screen. Mga classmates and batchmates of my elementary education, high school education, and college education. Okay, mga colleagues in my previous countries work in Taiwan, Abu Dhabi, UAE, State of Qatar. Okay, like that. In Jubail, in Al Kubar, something like that. I've been there also. Okay, and now presently here. Okay, so kung nanonood kayo, just keep tuning, guys, for my YT channel. Okay, nakaloka. Okay, ito, we try this one kung naabag yung siya ko in charot. Oh, wow! Hanap yapon siya. Vague. Vague meaning unclear or unreadable. Okay? Vague. Right? opaque. Wow. Talaga. So it's gonna be like this, 200 kilogram per hour. Wow, 200 kilogram per hour. You should know that directly. This is a mass flow rate. Ganun. Something like that. Okay?